This conference will now be recorded.
Ma, is it audible to everyone? Good morning to everyone. Visibility ఉందా? Tell me whether it is visible and audible. All the session chats, Dharani is present today. చూడండి ధరణి వచ్చిందా? Dharani and Soumya. First Dharani you have to check. Deepika, Chakrapriya and Lohitapriya, whether they are present or not. Okay, sorry, I'm in the rehearsal room. Huh? Sorry, I may remain in the rehearsal room. Sorry to everyone, I remained in the rehearsal room. There I am presenting after now. So ఇంకొకసారి సాంగ్ ధరనే ఉందా?
Yes, sir. ఉన్నాను.
So you check whether all the presenters are there or not. And ఈ సాంగ్ అవుతానే స్టార్ట్ చేయి. ఇది నేను ఇంకొకసారి పెడుతున్నాను.
Okay, sir.
So after immediately finishing of this song, you can take your session. So good morning to everyone.
Good morning, sir. Good morning, sir.
So sorry everyone for the delay. So today I remained in the rehearsal room. That is why I become late today. ఇంతసేపు సెమినార్ హాల్ అనుకుని నేను రిహార్సల్ రూమ్లో ప్లే చేస్తాను ఈ సాంగ్. మా ఇక్కడ చెప్పండి, ఇప్పుడు గో టు మీట్లో ఉన్న వాళ్ళకి గూగుల్ మీట్లో ఉన్న వాళ్ళకి కరెక్ట్ డిస్ప్లే వస్తుంది కదా, బోత్ ఆడియో యాజ్ వెల్ యాజ్ వీడియో.
Yes, sir. Yes, sir.
Both people staying in GoToMeet as well as Google Meet. So if it is clear, then you can continue. The session chair can take the chair and continue.
Okay, sir. Thank you. A very good morning to all. My name is Dani. I am from EPO section. Now I am the teacher of this 9th session. First of all, I warmly welcome all the faculty members and the students to the 9th session of the ISGPM 2020 program. Now, firstly, I welcome Ms. J. Deepika to give her seminar on the topic of fluid dynamics definition, streamline flow, and equation of continuity. Please welcome her. Ms. Deepika.
Thank you, Dani, for inviting me. First of all, a very pleasant good morning to our respected faculty and my dear friends. This is Mr. Deepika, ID number 0190287. Today, I am here to give presentation about the topic of fluid dynamics definition, streamline flow, and equation of continuity. Before I start my presentation, I will want to present my screen. I think my presentation is visible to all you.
Yes, Deepika, you can continue.
Thank you. First of all, we have to know what is fluid dynamics. What is the definition of the fluid dynamics? Here if we see, the study of fluids in motion is called fluid dynamics. That means when we study the fluids, when they are in motion, it is called fluid dynamics. In fluid dynamics, we mainly discuss and notice and observe that what is happening to various fluid particles at a particular point in a particular time interval. We have to mainly study that in this fluid dynamics. First of all, when we call a fluid study, we call the fluid study when the velocity of each passing fluid particle remains constant in time at a particular point in the fluid. To understand this clearly, we have to see in this diagram. Here if we see an orange line is drawn, let us assume this is the path of the fluid particles. Here if we see A and B are the fluid particles and R is the reference point. Here B has some velocity and A has some velocity. Both may have different velocities, but when B is moving from that point or its velocity may be changed. When it comes to R, its velocity may be something different, then it goes. Next, the previous particle A, when it is coming to the point R, it has the same velocity as that of B. For understanding clearly, I will say in Telugu, here B అనేది ఒక ఫ్లూయిడ్ పార్టికల్, అది ఒక వెలాసిటీతో ఉంటుంది. అది ఆర్ గుండా ట్రావెల్ అయినప్పుడు ఎంత వెలాసిటీతో ట్రావెల్ అవుతుందో తర్వాత వచ్చే ఏ పార్టికల్ కూడా ఆర్ గుండా అంతే వెలాసిటీతో ట్రావెల్ అవుతుంది. అంటే దాని మీనింగ్, the velocities of the fluid particles at a particular point, like that point R, they have same velocity at particular point in a particular time interval in the fluid. This we have to remember. Here if we see, this does not mean that the velocity at different points in space is same. Yes, here it has some velocity velocity at B, it has a velocity R. Now we have not to say that not all the points the velocity may be same. It may be different. When it travels from one point to another point, its velocity may change. In this steady flow, it follows a smooth path and the paths of the particle do not cross each other. They are moving parallel to one another. They are not touching each other. They are not crossing each other. So we have to mainly observe that what is fluid dynamics and when we call a fluid is steady. After moving to another topic, that is characteristics of an ideal fluid. Here we use the term ideal not exactly. In nature all are real fluids. There are no ideal fluids. The fluids which are near to the ideal have taken as ideal fluids. For solving the problems for theory, here we use the term ideal. Actually, there are no ideal fluids. Ideal fluids have many characteristics, but we have to discuss some main characteristics here. When coming to the first characteristic, it is incompressible. What means incompressible is, the meaning of incompressible is the density of the liquid is constant throughout the liquid. That means the density of the fluid particles in the fluid remains constant throughout the fluid. We know that density is equal mass by volume. Here mass is anytime mass is constant. So the volume will be constant. If we apply any pressure, then the volume is constant. Then we said the density is constant. So when the density is constant, it is incompressible. An ideal fluid has a characteristic of incompressible. When coming to the second point, it is non-viscous. Before to discuss about non-viscous, you have to know what is viscosity. Viscosity is an internal friction or the resisting force which stops the flow of the fluid. It is an internal friction, but in ideal fluid there is no viscosity. So ideal fluid and non-viscous. And coming to the third point, it is irrotational. In a mathematical way, irrotational meaning is different, but irrotational means the force of the flow of the fluid is smooth without any turbulence. So we see the word turbulence. What is the meaning of turbulence? When the fluid is flowing steadily in something like something of that fluid, it may move away. Some fluctuations will happen. Here if we see this figure, this is the turbulent flow. This is an example for turbulent flow. Instead of fluid is flowing steadily, some fluctuations will happen. Some fluid particles are touch each other and cross each other. This flow is called turbulent flow. Here, in ideal fluid, there is no turbulence. It is only steady flow. Fourth point is also same. It is capable of exhibiting steady flow. It is steady flow and exhibit test flow. Steady flow and similarly means what is meant by steady flow? The velocity of the fluid particles at a particular point in a particular time interval in the space is constant. The velocity is constant. When coming to the another topic, that is streamline flow and equation of continuity. Before we have discussed, we have to know what is streamline. What is the definition of streamline? Here, if we see, the definition of this streamline is the path taken by a fluid particle under a steady flow is called streamline. Simply said, like the path of the fluid particle when it's moving fluid is called streamline. Here, if we see this figure, we have to remember that streamline is not in a straight line. It may be a curved line, it may be in a straight line. Here, if we see, this is an straight line containing the particles P and Q here there. Here the tangents are drawn to show the direction of the velocity. This is the streamline. I want to show a video about streamline.
Streamline flow. A flow is said to be steady if the fluid velocity at a point does not change with time, and the statement holds for all the points. A streamline is a line drawn such that at each point its direction is the direction of the fluid velocity at that point. In a steady flow, streamlines are stationary and they do not cut each other. If they cut each other, then we say that the flow is turbulent.
Here we see what is a streamline. It is maybe in a curved line and it may be in a straight line. This is an example for streamline. Then coming to this figure B, from this figure we can derive the equation of continuity. Here if we see this figure, we observe that there are three regions here, P, R and Q. If we observe that the fluid particles are traveling from the region R to region Q to the region R. That means the fluid particles are entering through the region P and they are going out from the region Q. If we have taken the area of cross section of these regions, there let be the area of cross section at point B we have taken as AP, and at point R we have taken as AR, and at point Q we have taken as AQ. And we have taken the velocity or the speeds of these fluid particles at these regions. They might be at point P, the speed of the fluid particle that has taken Vp, and at point R we have taken Vr, and at point Q we have taken Vq. Here we observe the mass of the fluid particles entering to the point P we have taken as delta Mp, and the mass of the fluid particles that are going through R we have taken as delta Mr, and the mass of the fluid particles that are going out from the region Q we have taken as delta Mq. If we see here the mass of the fluid that is crossing to the point P or the area of cross section AP in a small interval of delta T, time of delta T, we have taken delta Mp is equal density P into AP into Vp into delta T. Here, why we have taken like this, I will explain. We know that density is equal mass by volume. That is, rho is equal m by v. From this, we get mass is equal density into volume. So we have written here density P. Then, in the place of volume, we have taken area into displacement. So we have written area here. In the place of displacement, we have taken velocity into time. We know that velocity is equal displacement by time. So we have taken by that displacement is equal velocity time. Velocity into time. So if we observe, we have to know that mass is equal density into volume. In the place of volume, we have taken area into displacement. In the place of displacement, we have taken velocity into time. Friends, I think all of you understand why we have taken like that. At the point P, this is the mass. When coming to the point R, we have taken delta Mr is equal to rho R into AR into VR into delta T. And at the point Q, we have taken delta MQ is equal to rho Q into AQ into VQ into delta T. We know that the mass is neither be created or not be destroyed. So, which amount of mass of the fluid particles entering to the point P is equal to the mass of the fluid particles that are going out from the point P. So, delta Mp is equal to delta Mp. We have known that. So, rho P, AP, Vp, delta T is equal rho Q into VAQ into VQ into delta T. Earlier, we have discussed the characteristics of an ideal fluid. For an incompressible fluid, the density is constant. So here, we have equated the densities. Rho P is equal, rho R is equal, rho Q. We know that mass is neither be created nor be destroyed. So if we equate this mass,
Miss Deepika, are you there? Miss Deepika. Miss Deepika, are you there? Your voice is not audible. Deepika? Hello?
Sorry, friends, this is the difficult platform due to some technical problem. I will continue. I will start my presentation. Here, if we equate these masses, here if we equate these masses, we get rho P into AP into VP into delta T equals rho Q into AP into VQ into delta T equal to rho R into AR into VR into delta T. From the densities are constant, so we can cancel here rho P, rho Q and rho R gets cancelled and delta T gets cancelled. Finally, we get AP into VP is equal to A into VQ is equal to AR. This equation is called equation of continuity. For these points, we have taken like these. This is general common. Generally, for all incompressible fluid, we have taken like AV is equal constant. This is called equation of continuity. AV is called constant. That means AV is inversely proportional to volume. If we see this figure, here we observe that the rate of cross-section at point R is more than the rate of cross-section at point P and Q. So R has the small velocity when compared to the points P and Q. P and Q have the greater velocity. Here AV is called as flow volume flux or flow rate. This remains constant throughout the liquid. When coming to another, the critical speed. What is meant by critical speed? We know about steady flow. This steady flow is only achieved in low flow speed. This low speed, the limiting speed is called critical speed. If the flow is the speed of the flow is increased by critical speed, then it loses its steadiness. It becomes turbulent. If the speed is increased by critical speed, when it loses its steadiness, something like a rock, an object is affected the flow, then it becomes turbulent. Here, if we see in this figure, first one figure is the laminar flow and second figure is the turbulent flow. In laminar flow, we have already called as steady flow as laminar flow. Here, if we observe, the forward arrows are the arrows of the increasing velocities and the backward arrows are the decreasing velocities. Here, if we observe steady flow, these fluid particles, the streamlines do not cross or do not touch each other. They are moving parallel to one another. But if we observe in this turbulent flow, when some rock or anything affected that flow, some fluctuations will happen. I have seen this in figure. Some streamlines may touch each other, may cross each other, and some fluctuations will happen. So this is turbulent flow. This is the difference between laminar flow and turbulent flow. So friends, I am concluding my presentation with these. If you have any doubts, please ask me. Thank you.
Nice presentation. Now, if participants have any doubts, you can ask her. Okay, I think there are no doubts. Ms. Deepika, you can ask questions to the participants.
Okay, thank you. Here, if we see in the presentation, here there is a question. The continuity equation is based on the principle of dash. I once again repeat it. The continuity equation is based on the principle of dash. A. Conservation of mass. B. Conservation of momentum. C. Conservation of energy. D. Conservation of force. You may tell the answer by on your mics, not through messages. While presenting, I am not able to see your messages. Please tell me the answer.
Conservation of energy.
Not Soumya. Conservation of mass.
Conservation of mass.
Yeah. Right answer, conservation of mass. The continuity equation is based on the principle of conservation of mass. Earlier we have seen that we have equated the masses. We said that the mass is neither be created nor be destroyed. This belongs to the conservation of mass. And coming to the another question, if we have this question, if a pipe is with flowing water has a cross-section area 9 times greater than the point 2, than at point 1, what would be the relation of flow speed at 2 points? I will set it clear. If we have 2 points, point 1 and point 2. Point 2 is the area of cross-section of point 2 is 9 times more than the area of cross-section of point 1. So what is the relation between them? The relation between the area of cross-section is 9 times more than point 1. Then what is the relation between their velocities? Here the answers will be there. Here the options will be there. Please answer. First option is the flow speed at point 1 is 3 times that at point 2. The flow speed at point 2 is 9 times that at point 1. The flow speed at point 2 is 3 times that at point 1. The flow speed at relation will depend on the viscosity of water. The flow speed at point 1 is 9 times than that of point 2. I think all of you understanding the question. The flow speed at point 2 is 9 times that at point 1. No, wrong answers. Wrong answers.
If flow speed relation will depend on viscosity of the water.
No, wrong answer.
The speed at point 1 is 9 times that at point 2.
Yes. Right answer. Thank you all for giving this wonderful opportunity. Especially my special thanks to our physics sir.
Any questions from the audience?
For giving this golden opportunity to me. Thank you.
Thank you, Ms. Deepika, for giving this seminar. Now, I would like to invite Ms. Devi Chakrapriya to give her seminar on the topic of Bernoulli's theorem. All the best, Ms. Devi Chakrapriya.
Thank you, Dharni, for inviting me. Good morning, everyone. My name is Devi Chakrapriya. I am from A4 section. I want to explain about Bernoulli's principle. Daniel Bernoulli is a Swiss scientist and mathematician. He won French Academy Prize for Mathematics 10 times along with Leonard Euler. He wrote a book named Hydrodynamica. It includes the mechanical properties of fluids. In fact, the Bernoulli's principle is an extract from this book. Even though fluid flow is a complex phenomenon, we can obtain some useful properties for study of streamline flow using the conservation of energy. Let us consider the fluid is moving in a pipe of varying cross-sectional area. Let the pipe be at varying heights as shown in figure. We now suppose incompressible and non-viscous fluid flowing steadily through a pipe. We go for what is meant by steady flow. The flow of the fluid is said to be steady if at any given point the velocity of each passing fluid particle remains constant in time. This does not mean that the velocity at different points is same. That is, at some other point, the particle may have a different velocity, but every other particle which passes the point behaves exactly as the previous particle that has just passed that point. Each particle follows a smooth path, and the paths of the particles do not cross each other. It is called a steady flow. I am again saying that the fluid pipe is incompressible and non-viscous. Bernoulli situation is the general expression that relates the pressure difference between 2 points in a pipe to both velocity units, that means the kinetic energy, and the elevation or height changes, that means potential energy. Consider the flow at two regions, one is the T and another is the TV. Consider the fluid is initially lying between B and D. Behind B infinitesimal interval at T. This fluid will have moved. Suppose V1 is the fluid at B and V2 is at B. Then fluid is initially at B has moved a distance V1 delta T to C. In the same interval delta T, the fluid initially at D moves to E. Distance equal to V2 delta T. Pressures P1 and P2 act as shown on the plane surface of areas A1 and A2, binding the two regions. The work done on the fluid at left end, that means DC, is W1. We know that work is force into displacement. We also know that force is also as present area. So W1 is equal to P1 into A1. And we know displacement is velocity into time. So W1 is equal to P1 into A1 into V1 into delta T. We also written as P1 into delta V. Delta V means volume. Volume delta V passes through the both regions. The work done by the fluid at the is W2. P2 A2 V2 delta V. We also written P2 into delta V or minus P2 delta V. Total work done. P1 minus P2 into delta V. Part of this work goes into changing the kinetic energy of the fluid. Is that part of this work goes into changing the kinetic energy and the gravitational potential energy of the fluid. If the density of the fluid is rho and mass is rho into delta V, because we know that mass is equal to density into volume. So delta M is equal to rho into delta V is the mass passing through the pipe in the time interval delta T. Then change in gravitational potential energy is delta U is equal to rho G delta V H2 minus H1. The change in its kinetic energy is delta K is equal to half rho delta V V2 square minus V1 square. We can employ this theorem which we discussed in our first semester with the volume of P1 minus P2 into delta V is equal to half rho delta V V2 square minus V1 square plus rho G delta V H2 minus H1. We know that each term by delta P1 minus P2 is equal to half rho V2 square minus V1 square plus rho G H2 minus H1. P1 minus P2 is equal to half rho V2 square minus rho V1 square plus rho G H2 minus rho G H1. We can rearrange it about terms to obtain half H1 is equal to P2 plus half rho V2 square plus rho G square. This is Bernoulli's equation. To refer to any two rotations along the particle. General P2 of Priya. As the next.
Sorry for the interruption. Some disturbance is there from you, Priya, from your back side. Please check it. No, I think there is no disturbance. No, we find some disturbance is there from you. Please check it once. Okay. Cool. Sir,
చెప్పండి.
the disturbance is from you, sir. Could you please off your mic?
నేను ఇక్కడ మైక్ చేస్తే గోటు మీట్లో ఉండే వాళ్ళకి వినిపించదు.
Okay, sir. Sorry.
మైక్ వేరే వాళ్ళు ఎవరైనా ఆన్ చేస్తారు.
Can I continue? Yes, yeah, you can continue. Okay, thank you. I'm saying that P plus of rho V square plus rho G is equal to constant. In words, the this relation is stated. As we move along this straight line, the sum of pressure to kinetic energy per unit volume and the potential energy per unit volume remains constant. Sorry, this is a mistake. As we move along a streamline is not correct. As we move along a streamline, it is a mistake. Please excuse me. In Bernoulli theorem, some limitations is there. It is only applicable for viscosity of non-viscous. That means not applicable for viscous fluids.
Many people are sitting on their mic. ఎవరైనా మైక్ ఆన్ చేస్తుంటే ఆఫ్ చేయండి. మైక్ ఇస్తుంది. If they are not experiencing this one. Sirisha, you have to switch off your mic. Go to mute. Go to mute the mic off.
Yes.
Sirisha, you have to switch off your mic and go to mute. Sirisha.
When can I continue? Yes, you can continue. We already said that in Bernoulli theorem some limitations is there. It is only applicable for fluids with zero viscosity or non-viscous fluids. Because in viscosity there is an internal process due to frictional forces, resulting in loss of energy. But according to energy conservation principle, no energy is lost, so it is not applicable for viscous fluids. And the restriction on application of Bernoulli theorem is that the fluid must be incompressible, as the elastic energy of the fluid is also not taken into consideration. The Bernoulli's equation also does not hold for non-steady or turbulent flows, because in that situation velocities and pressures are constantly fluctuating in time. We have limitations, but it has a large number of useful applications that can help explain a wide variety of phenomena for non-viscosity incompressible fluids. I conclude my lecture. Okay, thank you, Ms. Priya, for giving your seminar. Now, participants having any doubts, you can ask on your I think they have no doubts. You can ask questions to the participant prayer. Okay, Dani. I want to ask some questions. You are also comment me in comment box. I am able to see the messages with another account. I want to ask some questions. Why Bernoulli's principle is only applicable for non-viscous fluids and zero viscosity fluids?
What is the difference between non-viscous and zero viscous? Both are same.
Yes, sir.
Applicable. Oh, okay. I know.
Okay, sir. I'm asking you again why Bernoulli's principle is only applicable for non-viscous fluids. Because of frictional force. Yes, you are correct. And ID number 849, you are also correct. What is the relation between pressure and volume? Volume is inversely proportional to pressure. No, you are correct, Lohita. If you take a pipe in horizontal, the Bernoulli's equation becomes I'm asking you again, if you take a pipe in horizontal, the Bernoulli's equation becomes please say again, I can't understand. Your voice is breaking.
ఎవరు అక్కడ బ్యాక్గ్రౌండ్ మ్యూజిక్ పెడుతుండేది? There is so much noise. Really, this noise is not there.
Go to meet లో ఎవరైనా ఆన్ చేశారేమో సార్ మైక్. ఎవరు లేదు సార్ ఆన్ చేసిన వాళ్ళు.
Go to meet ఆఫ్ లో పెట్టుకున్నాను అందరివి. All are in off condition only. Where is this noise is coming from?
Again, giving the answer. If anyone, please say. P plus of rho v square is equal to constant. We go for next question. Who is the founder of mathematical physics? Yes, 903, you are correct. But according to our textbook, founder of mathematical physics is Daniel Bernoulli. But now Christian Huygens is correct. We thank you everyone to spend your valuable time for my lecture, and very special thanks to our physics sir to create this wonderful seminar. I am really saying from the bottom of my heart, I want to say something about our physics sir. He clarifies the doubts in any time. I asked a doubt 1 hour before this seminar and he clarified me. I am really thankful to you sir, and thank you everyone for giving this a very precious opportunity.
Thank you, Priya, for giving your seminar. It's very nice. Now, I would like to invite Ms. Kavita Priya to give her seminar on the topic of applications of Bernoulli's theorem. All the best, Kavita Priya.
Thank you, Dharmi, for inviting me. A pleasant morning to one and all. My name is V. Lohita Priya from A4 section. Now I want to present my screen. My topic is applications of Bernoulli's theorem. First of all, let us go to the Bernoulli's equation. As we move along the streamline, the sum of the pressure, kinetic energy per unit volume and potential energy per unit volume remains constant. Now, in this session, in this seminar, I am going to explain about applications of Bernoulli's theorem. Bernoulli's theorem is having many applications in daily life. Now I am going to explain about Venn meter, pitot tube, Parsellis law if time permits. First of all, Venn meter. The Venn meter is a device used to measure the flow speed of incompressible fluid in pipes. Hello, is it clear, Dharmi?
Yes, it's clear, Lohita.
The Venn meter is used to measure the flow speed of the fluid, either it is water or gas in the pipe. The working of Venn meter is based on the principle of Bernoulli's equation. As it is the application of Bernoulli's equation theorem, it is based on the Bernoulli's equation. It consists of a pipe or a tube with a broad diameter and a small constriction called throat at the middle. Now I am going to explain about the Venn meter's diagram. Here there is two parts. Here it is a chamber 1 and it is chamber 2. It is also known as throat. At chamber 1, the area of cross section is more, and at 2, area of cross section is less. At position 1, we are taking pressure, velocity, density and area of cross section with the subscript 1, P1, V1, D1, A1, and here we are taking with the subscript 2, P2, V2, D2 and A2. Here at 1, the area of cross section is more. At 2, that is throat, area of cross section is less. We also have converging part and diverging part. Please note that. And according to the equation of continuity, area is inversely proportional to the area of cross section is inversely proportional to the velocity, or velocity is inversely proportional to the area of cross section. So here area of cross section is more, so velocity is less, and at throat area of cross section is less, so velocity is more. Now coming to the pressure difference, here because the horizontal velocity is more, the horizontal force is at chamber 1, the horizontal velocity is less, so that horizontal force is less and the normal force or vertical force is more. According to the definition of pressure, it is defined as the normal force to the area. So we take here normal force, that is more, so pressure is more at chamber 1, and at chamber 2 horizontal velocity is more, so horizontal force is more, so that normal force is less. So here pressure will be less. It can be also rememberable by this. If we prepare well with high velocity for examinations, the exam paper will keep less pressure on us. Like at chamber 2, if we prepare little with the low velocity for examination, then the exam paper will put a high pressure on us, like chamber 1. Now if we apply Bernoulli's equation at 1 and 2 positions, we get this equation: P1 plus half rho 1 V1 square plus rho 1 GH1 is equal to P2 plus half rho 2 V2 square plus rho 2 GH2. Since the fluid is incompressible, and Deepika already said that incompressible means the volume of the fluid remains constant, so that the density also remains constant. So we have delta 1 is equal to rho 1 is equal to rho 2 is equal to rho. And for equilibrium conditions, we take H1 is equal to H2. Then the equation becomes P1 minus P2 plus half rho into V1 square minus V2 square is equal to 0. And it can be also written as P1 minus P2 is equal to half rho into V2 square minus V1. We simply bring half rho into V1 square minus V2 square to right side. Now, according to equation of continuity, we also said AV is equal to constant, or A1 is equal to V1 is equal to, A1 V1 is equal to A2 V2. So that V2 is equal to A1 by A2 into V1. Since I already said A1 is greater than A2, V2 is greater than V1. This change in speed of fluid causes change in pressure at points A and B. In such a manner, P1 is to explain this. H1 is greater than H2, and here in the diagram we took H1 minus H2 is equal to H. Please note that. Now here if we also know that P1 minus P2 is equal to rho G into H1 minus H2. According to the gauge pressure, P1 minus P2 is equal to rho GH. We take it as equation 2. Now from equation 1 and 2, if we substitute equation 2 in 1, we get half rho into V2 square minus V1 square is equal to rho GH. From that, we also write V2 square minus V1 square is equal to 2GH. By substituting V2 is equal to A1 by A2 into V1 in equation 3, we get V1 square into A1 by A2 whole square minus 1 is equal to 2GH, or V1 is equal to square root of 2GH by A1 by A2 whole square minus 1. Ultimately, if we substitute V1 in equation 3, we also get V2, the value of V2. And we have to note that ventimeter is applicable for incompressible fluids, I already said. Therefore, the speed of the fluid flow V1 and V2 can be obtained by using ventimeter. This is the application of Bernoulli's theorem and explanation of ventimeter. Now let us move on to the pitot tube. Pitot tubes are a common type of insertion flow meters named after a French scientist, Henri Pitot, used to measure the velocity of the fluid through it and in turn to calculate the velocity of boats, aeroplanes, etc. Pitot tube is used to measure the flow speed of the air or water, that is fluid, under the transport material. Either it is boats or aeroplanes. The mechanism of pitot tube is based on Bernoulli's principle, as it is the application of Bernoulli's theorem. It uses Bernoulli's equation. Here we have pitot tube. This is a pitot tube, typical pitot tube. We have here two chambers. One is with red color and another is with green color. In chamber 2, these lines are streamlines. And in chamber 2, as the door is completely open, all the air will gets into the chamber 2 and stacked here, and the pressure will be increased. If so, pressure will be increased, then the velocity of the streamlines or fluid particles will come to rest position and the pressure will be increased. This pressure in chamber 2 is stacked, so that this pressure is called as stacked pressure. And in chamber 1, a small hole is kept at the top, so that a very little amount of air will be flown into the chamber 1, so that here the pressure will be less, and moreover the air will tries to get out from the chamber 1. And here there is an orange color one. It is used to measure the pressure difference between stacked pressure and the pressure at the chamber 1. This is called as pressure differential. Finally, this is the pitot tube. And this is the explanation
For chamber 1, we have taken V1 and P1 pressure and velocity, and for chamber 2, we have taken pressure and velocity as P1 and PS and V2. Now, if we have to consider that both the chambers are at the same height horizontal to the flight. So they are at the same height. Both chambers are at the same height. Now applying Bernoulli's equation for chamber 1 and 2, we get Ps plus half rho V2 square plus rho GH is equal to P1 plus half rho V1 square plus rho GH. As they are at the same height, rho GH cancels and V2 becomes 0. And finally we get the equation Ps minus P1 is equal to finally we get the equation V1 is equal to square root of 2 into Ps minus P1 by rho. Also, if we substitute Ps minus P1 is equal to rho GH from the Gauss pressure, the equation becomes, and the velocity will becomes square root of 2 into rho GH by rho. That implies V1 is equal to square root of 2GH. Where difference in pressure between the two chambers can be measured using the pressure differential. I already said this. And V1 represents the velocity of the fluid or the velocity of the plane. The velocity of the fluid under the transport medium is with the same velocity but in opposite direction. Please note that. And the petard tube is arranged for the plane like this horizontally, so that the two chambers are at the same height. Also, please note this. Now, the explanation of petard tube is also completed. Now, let us move on to the Torselli's law. Torselli discovered that speed of efflux means fluid outflow from an open tank is identical to that of freely falling body and is called Torselli's law. The velocity of freely falling body, we know that from the kinematic equation, v square minus u square is equal to 2as. For a freely falling body, we get v is equal to square root of 2gh. Please keep that in mind. Now let us go to the derivation part. Let us consider a closed tank of cross-sectional area A2. Here is the picture. Cross-sectional area of A2. This is all fluid. And from the height y2 from the bottom, and for a tank they kept a small hole at the middle. It is at the height of y1 from the bottom, and y2 minus y1 is taken as h. And here that hole, the cross-sectional area is taken as a1, as it is very small. It is taken as a1, and here velocity is taken as v1, and at a2 velocity is taken as v1. Pressure at area of cross section A2 is taken as P2 and is also equal to P. Pressure at area of cross section A1 is taken as PA, that is atmospheric pressure, because it is open. So here,
sorry for interrupting you. The screen is about petard tube. Please change it as a Torselli's law.
I have already changed it. Now is it visible, Priya?
No, Lohita. It is about petard tube.
Okay, I am presenting again.
Okay.
Is it clear?
Okay.
Torselli's law. Torselli discovered that the speed of efflux fluid outflow from an open tank is identical to that of freely falling body and is called Torselli's law. We also explained this. Now let us go to the derivation part. Let us consider a closed tank of cross-sectional area A2 filled with a liquid of density rho. Density will be constant as it is incompressible fluid. Now I will explain the diagram. Here there is a fluid of area of cross-sectional area A2 at the height of y2 from the bottom, and the tank has been kept a hole at the middle, that is at the height of y1 from the bottom. Here the area of cross section is small and it is denoted as a1. Here velocity is v1 at the area of cross section a1 and the velocity is v2 at the area of cross section
A2. And the pressure at area of cross section A1 is taken as atmospheric pressure as the hole is open, and the pressure at area of cross section A2 is taken as T2 and equal to P, and the difference of Y1 and Y2 is taken as H. Now according to the equation of continuity, A1 V1 is equal to A2 V2, and we get V2 is equal to A1 by A2 into V1. So now A1 is very small, so that A1 by A2 will be negligible or equal to 0, nearly equal to 0. Anything into 0 will be 0. Then V2 is 0 or negligible. Please note that V2 is negligible and we are taking it as 0 here. Now if we apply Bernoulli's equation at area of cross section A1 and A2, we get the equation P2 plus half rho V2 square plus rho G Y2 is equal to P1 plus half rho V1 square plus rho G Y1. We substitute V2 is equal to 0, then half rho V2 square will be cancelled. We get rho G into Y2 minus Y1 plus P2 minus P1 is equal to half rho V1 square. Finally, we get P1 is equal to square root of 2GH plus 2 into P minus PA by rho. If we consider PA is far greater than PA, then 2GH can be ignored, because if P is more greater than 2 into PA minus P, 2 into P minus PA by rho will be more, and then 2GH will be ignored. Then the velocity becomes square root of 2 into P minus PA by rho. This situation occurs in case of rocket propulsion. This is used during the propulsion of rockets. Next, on the other hand, if the tank is open at the top, we have P is equal to PA. If the tank is opened at the top also, then here also the pressure will be equal to atmospheric pressure, and finally PA minus PA will become 0. So 2 into P minus PA by rho becomes 0, and the finally velocity becomes square root of 2GH. This is similar to the speed of the freely falling body from a height h, and hence the equation is called as Torselli's law. This V1 velocity is equal to the kinematic equation V square minus U square is equal to 2AS. From the kinematic equation V square minus U square is equal to AS, we get V at the height h, V is equal to square root of 2GH, and this velocity and that velocity are equal. This is called Torselli's law. I am concluding the topic by Torselli's law. Now anyone can ask questions.
Thank you, Ms. Lohita Priya, for giving your seminar and getting aware of applications of Bernoulli's theorem in our daily life. Thank you very much. Now I would like to invite Ms. Akila to give her seminar.
Any questions from the audience can be asked by Lohita.
Sorry, sir. Are there any questions from the audience on the topic of applications of Bernoulli's theorem? Okay, I think they don't have any doubts. Lohita, you can ask your questions to the participants now.
Thank you very much. I ask my questions by presenting my screen. Please answer me by switching your mics on, because I am unable to see the answers while presenting. My first question is about Torselli's law. The correct assumptions made to perform a Venn-meter experiment is or are: A, that Bernoulli's theorem holds good; B, that the equation of continuity is maintained; C, that the fluid used is highly incompressible; D, that all of the above are true.
All of the above are true.
Yes, exactly, you are correct. All of them. My next question is also about Venn-meter. When the ventimeter is inclined, that means it is inclined at an angle, then for a given flow, it will show dash readings. Options A same, B more, C less, D none of the above.
C less.
Please repeat again. C less. I didn't understand. Please repeat again. C. No, it's wrong. C is wrong.
None of these. B.
No.
More B.
The answer is yes, same. Because even the ventimeter is inclined, all the values will be same. Even the heights also, difference of heights will also be same. So the readings will be same. My next question is about pitot tube. How does the pitot tube help in measuring the air speed? Using temperature, using velocity, using Mach number, using the pressure difference.
Using the pressure difference.
Yes, correct. The answer is D, using the pressure difference. My next question is also about pitot tube. In a pitot tube, the kinetic energy is converted into dash. A. Potential energy, B. Total energy, C. Pressure energy, D. Internal energy.
Potential energy.
No, potential energy is wrong.
Internal energy. Internal energy.
No. And the answer is no. The answer is C. Pressure energy. Because as velocity is becomes zero, the kinetic energy is converted into pressure energy, so there forms stacked pressure. And my next question is about Bernoulli's law. What is known as speed of a flux in Bernoulli's law?
Fluid outflow.
Yes, the speed of fluid outflow. So by these questions, I am concluding my seminar here. Thank you all for spending your valuable time with my seminar and cooperation. And my special and sincere thanks to our physics sir, Dr. R. Balkrishnaya sir, for giving me this precious opportunity. Have a nice and colorful day. Thank you.
Thank you, Lohita, for your presentation. It's very nice, and your questions are also very nice. And sorry for whatever happened. Now, I would like to invite Miss Akila to give her seminar.
Good morning to all. Okay, go to meet. Okay, we can start, Akila.
My name is Akila from FI section. Today my topic is about Hooke's law. What is meant by Hooke's law?
You can turn on your camera also if possible.
Hooke's law is, first of all, we explain about what is meant by elasticity. Elasticity is a fundamental mechanical property. Example, when we apply a force on an object, it regains its original position and shape. Then Hooke's law means the maximum amount of stress we can apply an object so that material do not go from elastic nature to plastic nature. This is meant by elastic limit. Hooke's law. It is stated by the Robert Hooke, an English physicist. It is an empirical law. It was stated by in the year 1660. It states that within the limit of elasticity, the stress induced in the solid due to some external force is always in proportional with the strain. It means sigma is directly proportional to epsilon. Sigma means it is the symbol of stress, and epsilon is the symbol of strain. This is the relation between stress and strain. And the chains take different forms. And the Hooke's law means sigma is directly proportional to epsilon. Sigma is equal to epsilon E. E means modulus of elasticity. And the MKS units are Newton per meter square or Pascal.
Okay, continue.
Ante sir, inka over. Thanks for giving
Okay.
this wonderful opportunity.
Okay, Dharani, you continue to the next person.
Okay, sir.
Okay, sir. Thank you, Mr. Akila, for giving your seminar.
And
Now I would like to.
doubts can be
Sir?
asked. Questions can be asked
Doubts,
by.
sir.
Questions can be asked
Okay,
by.
the questions can be asked from the participants. If you have any doubts, ask them.
Otherwise, Akila will ask you some questions.
I think they have no doubts. Actually, you can ask them questions.
Who stated the empirical law means Hooke's law? Who stated the empirical law means Hooke's law in which year?
1660.
Correct. Who stated that? What is the MKS units of modulus of elasticity?
Newton per meter square or Pascal.
Okay, thank you.
Thank you, Akila. Thank you very much. Now I would like to invite Miss Pavni to give her seminar on the topic of gravitational potential.
Thank you, Dharani, for inviting me. Hi, good morning, one and all. Myself, I am Pavni Impolu from A5 section, having ID number O190278. Today's my topic is gravitational potential. Let's have a look on gravitational potential and what are the uses. I would present the screen. First, we see gravitational potential. Gravitational potential, the amount of work done in bringing a unit mass from infinity to a point in the gravitational field is gravitational potential. The gravitational potential energy of a particle of unit mass at a point is called gravitational potential at that point. The units, the CGS units of gravitational potential are H per gram, or SI units are Joule per kg. It is always negative since gravitational force is always attractive in nature. We take a brief look on gravitational potential. In classical mechanics, the gravitational potential at a location is equal to the work or energy transfer per unit mass that would be needed to move an object to that location from a fixed reference location. It is analogous to the electric potential in the role of charge. The reference location where the potential is zero is by convention infinitely far away from any mass, resulting in a negative potential at any distance. At finite distance, the finite distance in mathematics, the gravitational potential is also known as the Newtonian potential. And the fundamental is the study of potential theory. It may also be used for solving the electrostatic and magnetostatic field episodial bodies. And the formula of gravitational potential P is equals to mg delta H. P equals to potential due to gravity and G equals to acceleration due to gravity. M is the mass and delta H is the distance above a surface such as the ground. I want to give some examples to it. Examples of gravitational potential energy. When something has high position, its gravitational potential energy is high. For example, a book on a high book shelf has a higher gravitational potential energy than a book on the bottom shelf because it has further to fall. Other examples of items with gravitational potential energy include: first one is a raised weight. Second one is water that is handed down. And third one is a car that is parked at the top of a hill. Fourth one is a snowpack. Fifth one is a yo-yo before it is released. Sixth one is river water at the top of a waterfall. Seventh one is a book on a table before it falls. Thank you for giving this wonderful opportunity. If you have any doubts, please ask me.
Thank you, Pavani. If audience have any doubts, you can ask her.
Hello. Hello, sister. ఇలా మీ స్టార్టింగ్ లో అనలాగస్ అని చెప్పారు కదా ఒక పదం స్టార్టింగ్ పారాగ్రాఫ్
Analog.
సరే కొంచెం మీనింగ్ చెప్పండి.
Analogous meaning now.
అవును.
Wait, brother. అంటే మనం దేంతోనైనా కంపేర్ చేస్తున్నప్పుడు బ్రదర్.
ఓకే.
Anyone have doubts? Okay, Pavani, you can ask questions now. Yeah, thank you. How do you calculate gravitational potential? Once again, I repeated. How do you calculate gravitational potential? One of you, please. Okay, I tell the answer. Gp equals to mgh. And second question is, where is gravitational potential 0?
Center of Earth.
No. Center of Earth. First one is surface of the Earth. Infinity. Yes, you are right, Nasima. And third question is, what is the SI unit of gravitational potential? Joules per kg. Joules per kg. Yeah, it's right. Thank you, Ananda, to give this a golden opportunity to me. Thank you. Thank you, Pavani, for giving your seminar. Okay, now our session is completed.
You can
I'm very glad to.
You can announce the name
Sir?
of Sirisha.
Okay, sir.
మొన్న మిస్ అయింది కదా అమ్మాయికి, she is interested in you.
Okay, sir.
So you can present her.
Okay, friends, we have another presentation. Now I would like to invite Miss Sirisha to give her presentation.
Sirisha, you can
All the
switch on
best.
your mic now from GoToMeet. Sirisha, you can switch on your mic from GoToMeet now. Sirisha, are you able to listen my words? Okay, you can present your presentation. Start your presentation now. Okay, start. What is what? First, introduce yourself and say thanks to the chair and continue your topic. Are you ready to present or not? Continue, ma'am.
Yes, sir. First of all, I'm telling about Archimedes. First
Okay,
of all, I am
continue.
telling about Archimedes principle. Okay, sir. What is meant by Archimedes principle? When a body is partially immersed in the fluid, exerting an upward thrust equal to the weight of the displaced water. This is called Archimedes principle. So fluids appear very partially to the object placed in it. It is wholly or partially immersed in the fluid at rest. The fluid exerts principle. When we take the beaker, when you fill some fluid in the beaker, when we take the beaker, when we fill some fluid in the beaker, we will keep the hand in the fluid. So, Dharani,
Voice is not clear.
signals ఇప్పుడు వస్తుందా ధర్ని వస్తుందా
Okay, okay, Sirisha, you can continue.
Okay, what is the Archimedes principle? When we take the beaker, when we fill some water in the beaker, when we get the hand in the beaker, the water rise in the water display in the water display in the beaker. సో అంటే ఆర్కిమెడిస్ ప్రిన్సిపల్ అంటే మనం ఒక తీసుకున్నప్పుడు దాని కొంచెం హ్యాండ్ పెట్టినప్పుడు వాటర్ అనేది
Okay, there is a problem, might be problem. Network issue. Okay, you can close the session now. Dharani.
Okay, sir. Thank you, Sirisha. Thank you for your presentation. You can ask questions. Participants, if you have any doubts, you can ask her.
She has turned off her mic.
Okay, sir. Sir, can I close the session?
Close and we will announce we will continue after 11 o'clock.
Okay, sir. Okay, friends, the session is completed. Thank you for giving me this opportunity. And thanks to all the participants who have given this presentation session. Our next session, sir.
శిరీష మళ్ళీ మైక్ ఆన్ చేస్తుంటే ఓకే యూ కంక్లూడ్ ది సెషన్.
Okay, sir. Now our next session chair will be Miss S. Soumya. Please welcome her. And the next session will start at 11 o'clock sharp. Thank you. And my special thanks to Balkrishna sir for giving this opportunity and conducting such an ideal seminars for the students. Thank you, sir.
Okay, it is break time now, so we will be meeting again here by 11 a.m. sharply within 5 minutes. Meanwhile, if any other students are also interested, you can also give your names so that we can extend 10 or 20 minutes more after 12 o'clock also. So next section chair Soumya is ready there. Soumya. Lakshmi Narayana, you call Soumya. Be ready by 11 o'clock sharply.
Okay, sir.
Sir, Bhavani wants to tell her presentation, sir.
Okay, you can take the chair and announce her name after the first presentation. So first presentation is the schedule.
Okay, sir.
First schedule ప్రకారం పిల్లు ఆ presentation అయిన తర్వాత you can call Bhavani.
Okay, okay.
So now you can start your session by introducing yourself.
Hello, friends. Very good morning to all. I am Soumya. I am one of the student conveners of ISGPM 2020.
Presently you are session chair only. Then you can change your role in the middle.
Yes, sir. Today is the last session of our seminar. That is our 10th session. Now I would like to invite Ms. Lalita Devi to present her seminar about surface tension and surface energy. Let's invite her.
Thank you, Soumya, for inviting me. Good morning to one and all, respected sir. Myself, Lalita Devi from AO section. Today, I am going to discuss about the topic surface tension and surface free energy. Firstly, we should know about the surface tension. Surface tension is defined as the force acting on the surface of the liquid at right angles to any line of the length of the surface in 1 meter. I will present my screen to understand more. Up to the phone. Acting on the molecule.
Lalita, your presentation is not visible to us.
Not visible and also not audible too.
Please, you can change your place.
Is visible to all? Soumya?
Yes. Okay, you can proceed, Lalita.
Consider a molecule present in the phase of water which is fully surrounded, named as D. And a molecule which is partially surrounded by neighboring molecule is named as A. Is attracted equally in all the sides of neighboring molecules. Therefore, a molecule in the bulk of the solution is distributed more or less simultaneously. Hence, the net pull acting on the molecule B is 0. Surface tension. The coercive forces among the liquid molecules are responsible for this phenomenon. Consider a molecule named as A that lies on the surface. It is partially surrounded by the other molecules. There is no molecule above it. This molecule is attracted by the molecule below it and experiences downward pull. The adhesive forces between the molecule A and above it are weaker. Then the coercive forces cannot balance the inward pull on the molecule A. If we see an image, in this image, these unbalanced molecules acting downward tend to reduce the surface area to minimum. Okay, now let us discuss about the definition once again. The force acting on the surface. The force acting on the surface of the liquid is called surface tension. Once again, I am repeating. The force acting on the surface of the liquid called surface tension. Friends, now let us see a daily life example about surface tension. Can anyone think why insects float on water?
Due to surface tension.
Yes. And said clarity. Water molecules are attracted each other when they are to other molecules. So they generate a force to stay together called surface tension. If the force that the insect foot makes on the water is less than the surface tension of water, that's why the insect will float on water. You can see in this image clearly. Let us see surface tension of some liquids. In this figure, surface tension decreases at higher temperatures. We can take example as ethanol. In 0 degrees Celsius, surface tension is 24.05. In 20 degrees Celsius, 22.27. In 40 degrees Celsius, 21.20. In 60 degrees Celsius, 18.60. In 80 degrees Celsius, 16.20. So, surface tension decreases at higher temperatures. There are different methods to tension like capillarized method, drop count method, and drop weight method. Now we are discussing about capillarized method. Here we can see in this diagram capillarized method. When the capillary tube is placed in the liquid containing beaker, the liquid rises up into a tube to a certain distance. This is because the adhesive forces between liquid molecules and gas molecules are stronger than coercive forces between liquid molecules. The rise in the tube continue until the upward momentum is balanced by the downward force of gravity due to the weight of the liquid. Now we can go into derivation part. Upward component. This force represents the surface tension of liquid gamma at any point on the circumference, given by the equation 1. Upward component A equals to gamma cos theta, where gamma equals to surface tension of the liquid, theta equals to contact angle between the surface of the liquid and capillary wall. The total upward force around the inside circumference equals to 2 pi r of the tube is upward component equal to gamma into 2 pi r cos theta, where r equals to initial diameter of the capillary M. Now, if you see this picture, water stood as in because water completely wets the capillary wall. For liquid used in pharmacy, it takes only cos theta approaches 1. Then cos theta equals to 1 and equation 2 changes to upward component. Sorry for the interruption. Please speak loudly. Okay. If we see in this figure, downward component, the contracting process is gravity and depends on the weight of the liquid in the capillary rise. Downward component B equals to mass of the liquid in capillary into acceleration. Mass up to lower viscous plus W into acceleration. W is the additional mass of water present above the lower meniscus. Then W can be disintegrated to a small quantity. Now B can be written as B equals to mass into acceleration. As we all know, mass can be divided into volume into density and into acceleration. Volume can be divided into cross-sectional area into height, into density and into acceleration. Cross-sectional area of force in capillary liquid pi r square into height h into density rho into acceleration g. At equilibrium, these opposite forces are equal. That is, A equals to B. That is, upward force equals to downward force. From this, we can get gamma equals to 1 by 2 r rho hg. Once again repeating, gamma equals to half rh rho g. This gives the surface tension equation. Here gamma equals to surface tension of the liquid. This is the equation of surface tension. Now report the free energy. The free energy is this. As shown figure. The side of AD within this figure. Here is a rectangle. ABCD as shown white in the figure. The one end is movable. A drop of solution. The side AD shows point stable on account of surface accepted by the soft flame. When force is applied downward, the flame gets stretched as the movable bar AD goes down until the flame breaks. When the applied force is less than it is required for breaking, the flame would be react on account of surface tension. The force F is applied on AD. It shifts movable wire to the distance of D to AD. The work done W is given by work done is equal to force into distance. Here distance is delta x. In this figure, we can see the deviation part. W is equal to F into delta x equals to gamma into 2 into L. Here 2 into L will come to 2 lengths into delta x. We get equals to gamma into 2 into L into delta x is considered as B into B dash. Then gamma into 2 into B and B dash is considered as area A, B, B dash and A dash. Finally, we get the equation W equals to gamma into delta A. Delta A, here delta A is area change. This is the equation of surface energy. W equals to gamma into delta A. Here W equals to work done or surface free energy in X. Gamma equals to surface tension. Delta A equals to the increase in area. Thank you, friends. Now let us see effects of surface tension. Surface tension will be reduced when the temperature of the liquid increases. This is due to the thermal expansion of liquids. This continues till the temperature of the liquid reaches the critical temperature of the liquid. At this point, surface tension becomes zero. So thank you, friends, for giving me this opportunity. Okay, Lalita. Friends, if you have any doubts regarding the topic, please turn on your mic and ask her. I think it seems to be no doubts for them. Now you can ask your questions, Lalita. Okay. Thank you, Soumya. What is the surface tension formula? Surface tension formula, can anyone say? Hello, anyone is there? Gamma equal gamma is completed delta of G. Sindhu, you are correct. taking another question. What is the surface tension at higher temperatures? It increases or decreases? Decreases.
Decreases.
Right? So, what? Decreases. Decreases. Okay. Formula for surface free energy? What is the formula for surface free energy?
W equal to gamma into delta E.
Now, thank you, Najima. Correct. What is the unit for surface tension?
Then per centimeters. And per centimeters are H.
Joule per meter square also. Okay, thank you, friends. For this, I completed my seminar. Thank you, friends. And special thanks to our physics sir, Dr. Balakrishna sir, for conducting such an ideal seminar for the students. Thank you, Soumya. Thank you, sir.
Thank you, Lalita. Thanks for your wonderful presentation. Now I would like to invite our next presenter, Miss Y. Bhavani, to give her seminar about buoyancy.
Thank you, Soumya, for inviting me to give my seminar. First of all, good morning to sir and all my dear friends. First of all, I would like to introduce myself. My name is Y. Bhavani. I am from A4 section. My ID number is 0190235. I would like to tell about the topic buoyancy. First of all, buoyancy is a term of physics which describes a type of force which is also known as the upthrust force.
Speak loudly.
And give the talk relaxedly without tension.
Buoyancy is a term of physics which describes a type of force which is also known as the upthrust force. This is an upward force which is created by fluid when an object is immersed into that fluid. Okay, I am presenting my screen. Okay, we will go for buoyancy definition. The resultant of all the fluid forces acting on the object becomes an upward force, and this force is called buoyancy force. I will repeat once again. The resultant of all the fluid forces acting on the object which is immersed in the fluid becomes an upward force, and this force is called buoyancy force. Okay, let us suppose take an object of mass m which is immersed into a fluid. Then gravitational force acting on the object and buoyancy force are opposite to each other. Gravitational force pulls the object in downward direction, whereas buoyancy force pulls the object in upward direction. That means gravitational force and buoyancy force are opposite to each other. Okay, let us see this. Buoyant force and density. If an object weighs more than the water it displaces, the object sinks. If the object has a greater density than water, and if an object is more dense than the fluid it is displacing, then the buoyant force on that object is less than the object's weight and the object will sink. Otherwise, if an object is less dense than the fluid it is displacing, then the buoyant force on that object is more than the object's weight and the object will float. I will repeat once again. If an object is less dense than the fluid it is displaced in, then the buoyant force on that object is more than the object's weight and the object will float. Let us see this picture. In left side, object is less dense than the fluid. So buoyant force on that object is more. So object will float. In the right one, object is more dense than the fluid. So beyond force on that object is less. So object will sink. Okay. Thank you for giving this wonderful opportunity.
Okay, Bhavani. Friends, if you have any doubts regarding the topic, please turn on your mics and ask her. I think no one has doubts, Bhavani. Now you can ask your questions.
Okay, I will ask my questions. First one, what are the factors that affect buoyancy?
Gravitation and object's weight.
Gravitation is correct, but object weight is not correct.
Beyond force. Upward force.
But
Density of fluid and volume of fluid.
density of the fluid is correct.
Object volume. And also volume of the fluid.
Volume of the fluid also correct. Okay, I will answer. Density of the fluid, volume of the fluid displaced, acceleration due to gravity are factors affect buoyancy, and mass of the immersed object and density of the immersed object is not factors of buoyancy. Okay, I will ask another question. If a heavy rock is placed in a bucket of water, the rock sinks to the bottom. Then what is the value of the buoyant force on the rock?
0.
Not 0. 0.
Okay, buoyant force is the weight of the volume displaced. Weight of the water displaced by the immersed object.
It is not a 0.
Okay, thank you, ma'am. Thank you for giving this wonderful opportunity to me. Thank you special thanks to my physics sir. Thank you, sir. Thank you so much. Thank you all.
Only the apparent weight of a floating object is 0, because that the weight of the object balances the buoyant force. So I have apparent weight equal to actual weight minus buoyant force. So from this formula we can say for a floating object, the buoyant force will be balanced by the weight of the object. So we get the apparent weight of a floating object is 0. But in case of a fully immersed solid, the buoyant force will be equal to the weight of the volume of the fluid displaced. So that is also we call it as the buoyant force. I hope all of you have understood. Okay, you can continue session chair.
Okay, sir. Now, in this presentation, as one of the student conveners of ISGPM 2020, on the behalf of the A4 and A5 sections, Student Organizing Committee, I am happy to announce that our 5-day internal online seminar on gravitational properties of bulk matter schedule is successfully completed. Before we conclude our program, I invite any input, comments, suggestions and feedback on our overall 5-day seminar program from the participating students that could help us together to move forward in encouraging our performance to much better levels in future.
So any feedback from the audience on the overall seminar? You can tell whether it is good or bad. Always some comments will be there. There is no chance for no comments. If it is good, you say good in words, not in text. You have to express in words. Or any suggestions?
Please turn on your mic and express your feedback.
It is very helpful to all, sir, in future.
All the participants are invited to express their views one by one. Switch on your mics and say in words from the audience. Whether how it is helpful to you, whether you carry on in the similar programs in future or not, or any suggestions, how best we can improve in future similar programs in terms of input from you. Whatever suggestions are welcome. Just switch on your mic and you can express your words.
Sir, this is very useful to us. We learned so much for this seminar. Thank you for this. I thank you, sir. I'm learned so much for this seminar. I'm the one of the part in student organizing committee. I'm so proud. Thank you for this golden opportunity, sir.
Okay, any feedback from the other session students other than F4 and F5?
Good morning, sir. My name is Bijishkan. I'm from F15. I grandly congratulate all the participants and section chair and especially you, sir. I cleared my all doubts and my problems regarding the physics, especially these subjects. Thank you, sir, for your connection for the class.
Okay, welcome. You are also welcome. In case you are interested, you can ask me any doubts by coming to any classroom or something. So you can also ask any faculty in physics department. They will be helpful to you all anytime. Okay, thank you. Any others?
Good morning to the respected sir and all my dear friends. I am Tejaswini of A13 section. I am very happy to be a member of the audience. And first of all, it is a wonderful idea to conduct a seminar by the students. I think every member of the ISGPM 2020 made the internal seminar successful. And we have learned many things in physics by this. And I think it is very useful for everyone to clear their doubts and to get more information on those topics. And it is a wonderful idea to conduct this seminar during this lockdown time. Sir, we have learned many things. Thank you very much, sir, for being a member of audience. Thank you, sir.
You are not only audience, you are a spectator also. And you can participate in the cultural activities also if you wish. Other section students also participate in the cultural activities if you wish.
Yes, sir. Thank you, sir.
Any feedback from others?
Thank you, sir, for conducting this kind of wonderful seminar to us.
You are the student convener. I am giving chance to other section students.
Thank you, sir, conducting this seminar.
Any improvements you have to tell, not the positives. Any improvements or suggestions are welcome. Not the positives.
By presenting the seminar, sir, we will forward the Stacia, sir.
Okay, it is nice. That is why that is the main purpose of the organizing the seminar, to erase your stage fear only in any forthcoming higher level seminars at the state level, institute level, or international, state level, or national level, international level. Such type of seminars and conferences and workshops will be conducted. So you can participate in those as a student. So this seminar is basically organized only to erase or only to remove stage fear from you from the stage itself only. At PUC 1 level, it's from PUC 1 itself. It will, if you plan to remove your stage fear, it will be better for your future academic career also. So that is the main motto of the organization of this seminar. For you know. Okay, any feedback from others? Okay, if there are no feedback from others, then you can continue your next part, Soumya.
Thank you for your valuable feedback, and we will surely consider your valuable feedback and suggestions. Now, I grandly invite Ms. V. Lohita Priya, one of the student conveners of ISGPM 2020, to express her vote of thanks.
Thank you, Ms. Sihat Soumya, for inviting me to express my vote of thanks. Good morning to everyone. As announced by the session chair, I am Ms. V. Lohita Priya from A4 section, one of the student convener of ISGPM 2020. I am very much delighted to express my vote of thanks on the behalf of the student organizing committee. Matrudevo Bhava, Pitrudevo Bhava, Acharya Devo Bhava. So, I am utilizing this opportunity to express my heartfelt thanks, starting with all our parents, supporting elders and teachers in the society who have played and or are playing their vital roles in bringing us up to these levels. We are able to stand before you today as the students of RGUKT AP with fulfillment of their own roles on their own efforts. Then I extend my sincere thanks to Government of Andhra Pradesh for providing us this opportunity through RGUKT AP. Starting from the leadership of our Honorable late Chief Minister Sri Dr. Y.S. Rajshekar Reddy sir, through our former Honorable Chief Minister Sri Mr. N. Chandrababu Naidu sir, to our ongoing Honorable Chief Minister Sri Mr. Y.S. Jaganmohan Reddy sir, for their establishment, extension and continuation of support respectively to our Rajiv Gandhi University of Knowledge Technologies, Andhra Pradesh, towards catering to the educational needs of gifted rural youth of Andhra Pradesh. I sincerely express my special thanks to our Honorable Founder, Vice Chancellor of RGUKT AP, Professor K.C. Reddy sir, who is currently holding the position of Honorable Chancellor RGUKT AP, and his ongoing administrative team members, Professor K. Hamchandra Reddy sir, Honorable Vice Chancellor of RGUKT AP, Dr. B. Sudhir Prem Kumar sir, respected Director, RGUKT AP, Ongole, and Professor L.D. Sudhakar Babu sir, respected Officer on Special Duty, RGUKT AP, Ongole and Srikakulam campuses, for their constant efforts in developing the university to the maximum possible standards, and we are sure under the capable administrative leadership of our Honorable Chancellor sir, we will surely achieve our academic goals in our lives with our constant dedicated efforts. Then I extend my sincere thanks to the administrative team of our RGUKT Ongole campus, Dr. I. Narasimhamurthy, Administrative Officer, Dr. K. Sugunarao, Student Welfare Dean, Mr. K. Sandhya, Ms. K. Sandhya, Associate Student Welfare Dean, Dr. M. Venkateshwar Rao,
Associate Student Welfare Dean, Department of Physics, Mr. K. Samuel, Chief Warden, Dr. G. Venkataya, Finance Officer, Department of Physics, Dr. G. Madhu, Controller of Examinations, Dr. P. Rangaswamy, Additional Controller of Examinations, Dr. N. Mohan, Establishment Session Coordinator and Head, Department of Physics, Mr. N. Mallikarjuna, IT Infra Coordinator, Dr. S. Ibrahim, Public Relations Officer, Mr. R. Dilip, Institute Civil Engineer, Dr. P. Kristaya, NSS Coordinator, Mr. P. Shivaprasad, Institute Electrical Engineer, Dr. Sheikh Mirawali, Stores and Purchase Coordinator, Dr. M. Anil Kumar, Dean Academics, Dr. V. Madhumohan, Additional Dean Academics, Department of Physics, Dr. K. Shivakumar, Associate Dean Academics, Department of Physics, Mr. N. Koteshwar Rao and Dr. M. Srinivas Reddy, Associate Academic Teams, as the presiding member in my district. On the behalf of the Student Organizing Committee, ISGPM 2020, I also express thanks to all the faculty members belonging to Department of Physics, in particular to sirs and madams who have guided their section students to attend the online seminar to make us a part of departmental event. Student organizers in response to the invitation made by our physics sir, Dr. R. Balkrishnaya, on the behalf of our A4 and A5 section Students Organizing Committee. Even though I feel little bit uncomfortable to express my special thanks to our A4 and A5 section Student Organizing Committee members, being one of the student convener taken the responsibility of expressing vote of thanks, I feel it is my responsibility to express my sincere thanks from the deep of my heart to all my co-student conveners, Miss M. Dharani, Miss Y. Bhavani, Miss C.H. Soumya, Miss J. Lahari, and Mr. V. Lakshmi Narayana, and my co-student organizing committee members, Miss B.G. Sirisha, Miss Sheikh Kausar, Miss T. Mahita, Miss B. Satyanusha, Miss Sheikh Nazima, Miss B.V. Chakrapriya, Miss A. Maunika, Miss N.V. Anita, Miss K. Devipriya, Miss J. Deepika, and Miss G.C. Meghna for their excellent teamwork and time management, without whose cooperation we might not have completed the program in a successful manner in the scheduled time period, and it remains as a sweet memory for all of us in our future for successful organization of the seminar at this 10+1 academic stage itself. I extend my sincere thanks to all the remaining students who have presented their topics and or made their active participation in the seminar in making the seminar a grand success. Last but not least, I express my soulful thanks to the divine nature for promoting our enthusiasm in the positive direction in looking after us with all needful cooperation from the root levels, and I hope all of us will continue the same positive spirit in our future too, for being the good civilized human beings in our careers and lives under the true spirit of the state and the nation, Satyameva Jayate, and unity in diversity. Thank you. Yours, Ms. V. Lohita Priya, on the behalf of Student Organizing Committee, ISGPM 2020.
Thank you, Ms. Lohita Priya, for the vote of thanks. Now I am concluding my session and hence our 5-day seminar program with National Anthem. Now I invite all the student conveners, organizing committee members, and all attendees of the seminar to mix your voice with the National Anthem being played by Ms. Lahari or Mr. V. Lakshmi Narayana.
Now it is the time for National Anthem to be played by either Lakshmi Narayana or Lohita Priya, Lakshmi Narayana or Lahari, and all of you mix the voice together. यमुना गंगा उच्छल जलधि तरंगा तव शुभ आशीष मागे
तव जय गाथा जन गण मंगलदायक भारत भाग्य विधाता जय है जय है जय 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 है
Now I would like to invite Ms. Saira Banu to give her opinion.
Thank you, Soumya, for inviting me. A pleasant good morning to our respected sir and my dear friend. This is Sheikh Saira Banu from A5 section. Today I am here to give a small speech about this program. First of all, sincerely, I want to thank our physics sir because encouraging the students to participate in several cultural activities and to forget the stage fear and to improve the communication skills towards us. And the students who participated in the presenting their seminars, they presented their level best to give their presentations and it worked out very well. I want to thank the audience for encouraging the people to give their presentation by attending the 5 days seminar presentation. I want to thank the people who showed their interest to give the presentation from other sections like Miss Surekha to share their knowledge with us. Mainly, I want to thank conveners, session chairs, and presenters for completing this ISGPM 2020 program with grand success. I hope that all the students who attended the seminar presentations enjoyed very well and they gained the knowledge from these presentations. Once again, we are very thankful to our physics sir for encouraging us and giving very good compliments after the presentations. And finally, we are very lucky to be the students of Balakrishna sir and A4 as A4 and A5 students. We got a good opportunity to show our hidden talents in this program. Hope you all enjoyed and enjoying this program. And thank you for physics sir and my dear friends giving this golden opportunity. And thank you for spending your valuable time. Have a nice day to all. Thank you once again to all.
Thank you, Saira Banu. I would like to express my great thanks to our physics sir, Dr. R. Balakrishna sir, for giving a gold honor opportunity. Now our internal online seminar on gravitational properties of dark matter program is officially concluded. Now it is the time for cultural activities. I am handing over the session to the cultural activities team to plan their cultural activities. Thank you. Yours, Ms. K. Soumya, one of the student conveners of ISGPM 2020 on the behalf of the student organizing committee. Thank you.
So if you have planned any cultural activities, it is the time for you to now to plan your schedules accordingly by taking the chair. Is there anyone who is handling the cultural activities schedule? Are there cultural activities planned by you or not? If there are any cultural activities, you come and participate. Otherwise, you can play the song finally. So, what is the song? That is, I have sent in WhatsApp yesterday night. Asatoma Sadgamaya song you can play. Cultural activities team has to come fast without making time delay.
Now it's time for cultural activities. Now I request ID number 779, Manjushri, to come forward and sing a song.
Thank you, Lohita, for inviting me. Hi guys, my name is Umaguru Nagamanjushri. I'm from A13 section. My ID number is 090779. Today, in this great event, I want to sing a traditional song. Mahaganapatim Manasa Smarami Mahaganapatim Manasa Smarami Mahaganapatim Manasa Smarami Vasishtavamadivari Vandita Mahaganapatim Mahadeva Sutam Devasutam Guru Guha Nutam Mahadeva Sutam Guru Guha Nutam Mayakoti Prakasam Satam Mayakoti Prakasam Satam Mahakavya Natakari Priyam Mahakavya Natakari Priyam Moshika Vahana Modakapre Mahakavya Natakari Priyam Moshika Vahana Modakapre Mahaganapatam Thank you friends, giving this wonderful opportunity. Thank you sir. Thank you so much.
Who is the session chair for cultural activities? They have to manage. Somebody from the student organizing committee members be the
Thank you,
session
Manju,
chairs.
for your sweet song.
Okay, continue.
Now I request Pawnee from A5 section to present her cultural activity.
Thank you for inviting me, Rohita. My name is Tony Ampolu. I am from A5 section, having ID number 0190278. I would like to sing a song. Gananayakaya Ganadhaivakaya Ganadyakshaya Dhimahe Gunasariraya Gunamanditaya Guneshwanaya Dhimahe Gunadevaya Gunadeshaya Gunapravishya धीमहि एकदन्ताय वक्रतुण्डाय गौरी तनयाय धीमहि गणेशाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरी तनयाय धीमहि गणेशाय बालचन्द्राय श्रीगणेशाय धीमहि गणचतुराय गणतनय अनन्तरने पूजिताय गुरुकुलस्थायिने गुह्यप्रदाय गुरुवे गुणमवे गुरुदैत्यकलक्षेत्र गुरुधर्मपदाराध्याय गुरुपुत्र परदात्र गुरुपाखण्डकण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमस्ताय घोषयाप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गणेशाय बालचन्द्राय श्रीगणेशाय धीमहि. Thank you to give this wonderful opportunity to me.
Thank you, Pauli, for your active participation. It was so nice. Now I request anyone from the audience are interested, please come forward. Is there anyone interested from the audience for cultural activities? Please come forward. Seven 79, Manjushri, want to sing another song? Please continue, Manju.
Thank you, Lokita. भावमोलोन बाह्यमोनन्दुनो भावमोलोन बाह्यमोनन्दुनो गोविन्द गोविन्द अनिकोनो वो मनस्ता भावमोलोन बाह्यमोनन्दुनो ಅಚ್ಚುತೊಡಿತಡೆ ಆದಿಯುನಂತ್ಯವು ಅಚ್ಚುತೊಡಿತಡೆ ಆದಿಯುನಂತ್ಯವು ಅಚ್ಚುತೊಡಿತಡೆ ಅಸುರಾಂತಕುಡು ಅಚ್ಚುತೊಡಿತಡೆ ಆದಿಯುನಂತ್ಯವು ಅಚ್ಚುತೊಡಿತಡೆ ಆದಿಯುನಂತ್ಯವು ಅಚ್ಚುತೊಡಿತಡೆ అసురాంతకుడు అచ్యుతుడు శ్రీ వెంకటాద్రి మీదను అచ్యుతుడు శ్రీ వెంకటాద్రి మీదను అచ్యుత అచ్యుత శరణనవో మనసా అచ్యుత అచ్యుత శరణనవో మనసా భావములో బాహ్యమునందును గోవింద గోవింద అని కొనువో మనసా భావము బాహ్యమునందును. Thank you, friends.
Thank you, Manju. It's excellent. Anyone else from the audience, if interested, please come forward. It's the last call. Please come forward. Okay, if there is no one, I'm concluding the cultural activities program now. Thank you everyone for your participation. Thank you audience for your cooperation and appreciation of the participants. Thank you once again.
Lakshmanarayana, you play the Astama Sadgamaya song. You
Okay, sir.
play on screen. So as it is the COVID-19 pandemic situation, let us pray for the peace of the universe through this song. Okay, you can continue.
श्री गौरी नंदना देवा सिद्धि बुद्धि प्रदायका उत्तिष्ठ प्रमथाधीशा उत्तिष्ठ गणनायका
रघुपति राघव राजा राम पतित पावन सीताराम।
Okay, if anybody is interested, you can continue. Otherwise, we can close the session now. Can I close the program now? Lohita, you ask as the session chair of the cultural activities.
I am requesting again, if anyone ready, please come forward for cultural activities.
Okay, if there is no one, I am closing now. So all the best. We will meet again in near future on Sunday. All the best to you, and stay home and stay safe. All the best to you. Have a nice day.